Good. So we want to discuss about on how to set the graphic. Maybe you have set an exam, then you just want to put there the grid alone. You know, there's two format where this grid can be placed. One, the grid without the quotation. Then we have that two where we have the grid with the quotation. The grid without quotation and the grid with quotation. So we'll discuss all of them, the two, before we go now to the sample graphs, because the system will do all of those things. So quickly, if I go to the word, which is our site in location of that object, you go to insert, then you click the object drop down, then you click object. You give it time to load, then you go to FX draw, then you click OK. Good. So I must admit that that space where I was before I got to this system, it was the space where I needed to put there the grid. And before you put there the grid, you need to attempt that question so that you make sure that the grid that you are providing is suitable for that learner to use, because you might come up with a grid only to find that it cannot accommodate all those data provided in that table. So make sure that you yourself, you try that question somewhere on the paper, graph paper, so that you make sure that the grid that you are providing is accommodating all those values. So assuming that I have tried this question and realized that the grid that will accommodate this paper will be maybe of 13 division by 12 division, so that I have the x-axis 13 division, then the y-axis maybe I have 12 division, so I need to give them 13 by 12. With these tools, you go where we have the graph there, then you click the graph paper, because we need to give them graph paper. So when you click graph paper, you come and drag on your screen. Mine will be okay because I have been using it, but for your site it will not be like this one. So you select that grid, you right click. We start by setting these things. First, measure 1 pt. X measure and Y measure, the thickness or the width must be 1 pt. Then here the color, you make sure that you select this black. Here black. Then okay. Hapo pair ikuwe hiyo black. Then the X minor, the thickness, let it be just not as that one for the measure. So you can set it at 0.75. X minor and Y minor. Now its color, because we don't want to be, we want to be in position to differentiate the minor and the major. So instead of black for this one, I can use this one that is appearing to be gray like that. Then you click OK, so that the big lines or the major lines will be different from the minor. Then come here where you have the sizes. The sizes here, remember that one big square of that graph paper is 1 centimeter. 1 centimeter is the same as 10 millimeter. So where you have the major size, that's where we have one big square. Let it be 10 millimeter. 10 millimeter. Then here it will depend on the number of division you want to have in one big square. Like the next standard graph paper, it is 5 big square. So it will be this measure divided by 5 on a part upon 2. So the minor should be 2. But in case you are big square, you want it to have 10 division, upper minor, it will be 10 divided by 10. You find that this one will be 1 millimeter. Now when you are typing, type with those SI in it without a space, 10 mm, alafu 2 mm. Then, because we want to avoid this repetition, you click and set as a default, and if that sound is produced, then you click OK. So you'll find that will be your grid. So what is remaining is just to adjust your grid. So to adjust, remember that I've said that I wanted the X to be 13. So just count 1, 2, 3, 4, 5, 6, 7, 13 nafika hapo. So jinafika hapa, hii zingine ni wastage. Unakuja unashika huko kwa kona, alafu unairudisha hapo. Which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Kama ingekuwa haitoshi, ningeshika hapo, alafu ni pull outward. Na kama imepita, unashika hapo, then you pull inward. That is adjusting the y, the x. Now what about the y? Y tumesema square 12. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see that 12 is here. Unaona yangu ilikuwa imepita. So kupunguza ya juu, unashikia juu. Usishikie chini, ushikie juu. So that utaka kwenda hivi chini till the point utafika kwa hiyo line ya hiyo line ya 12. So after that you just close. So when you close you find that it's going directly to the word. Na utaona kwa hiyo space nitakuwa nimeiset hiyo grid, so I can just do alignment so that I click home, then alignment equal center. So you find that now that will be the craft paper where maybe students are going to perform those construction. Maybe the question that is on the grid provided, draw on the grid provided, draw. Hii ndio yenye watafanyia construction. Then there's another type of grid where, like for the transformation, you don't want this student to suffer in coming up with their Cartesian, because in transformation it appears tricky as some of the objects can appear in any quadrant. So you find that in that case, if you want to have to maybe make this learner to not have so much work to do, you will have to provide them the grid so that you make sure that given that grid with the Cartesian, it can be used by that learner just to do transformation instead of setting their axis. So if that kind of question appear and I want to give them a transformation, I just go to insert, then still qua object, then fx draw, like that. Good. Then from there I can remove this one. But now this time round, you'll not go to the graph paper because we are not giving them graph paper. We go to function graph. Alafu ukuje utrack hivyo kwa screen. So mine nimeitumia ndio maana imekaa hivyo, lakini yaka haitakaa hivyo. So right click kwake. Then you start by setting the grid. Uanze na grid. X measure iweke 1 pt. Y measure iweke 1 pt. Color hapa put it to be black. Na hapa black. Hapa na hapa black. That is X measure and Y measure. X minor thickness equals 0.75. X minor na Y minor. Sinaenda hivyo horizontal. X minor, Y minor. Then color uweke gray. This second color just after this black. Hii ndio nataka tuweke. Tusiweke hii zingine. Weka hii. Then you click OK. Same to here. Uweke hiyo. Then to avoid setting that grid, is set as default. Then you click it, OK. Then right click. Then from there, now we are almost through. I've drawn those transformation and I've realized that the minimum value of x coordinate in all coordinates, the minimum value of x coordinate in all coordinate, it is maybe -4. So if it's -4, I can give some allowance to -5. So unakuja under scale. You come under scale. A minute. So you have performed the construction, and then you find that you are on all your coordinate, the minimum value of x coordinate, it is -4. So if it is -4, or let me give it an allowance, something like a -6. So if it is -6, I need to give an allowance so that it is not on the last margin. So from -6, I can say that let my now Cartesian for x minimum to start from -7 or -8. Then again, I check the same coordinate, all of them after drawing in a piece of paper. I realize that the maximum value of x, it is maybe say 8. So if it is 8, it means that I can go to what? Something like if maybe the maximum value I find that it is something like 7. So if it is 7, I go to the for the graph, I can put it now at the 8, so that I make sure that all these coordinates are within. So your interface, after right clicking on that graph, you'll find that you go to scale. Then here is where we set down the scales. You'll find that your graph, maybe these boxes might be checked. Siko hapa na tick siko wamemark. So if it is marked, you need to remove those ticks. You remove these ticks zote. Ukishatoa uangalie tena hapa chini. Kama iko fixed, inamaanisha kwamba you cannot edit here. Unaona hata ni click, you cannot be edited. So unaiset free. Ukiweka free, inamaanisha kwamba unaweza fanya any editing. So I have said that I've tried and find that the minimum value of x, it is -6. So nikaipea allowance, nikaanzia -7. Then the maximum value of x from all those coordinates nimepata kwamba it is 7. So mimi naweza fika 8. Then ikishafika hivyo 8, nitajiuliza which scale yenye iko suitable. Venye unafanyanga tu kwa karatasi, kwa piece of paper, which scale is suitable. So utaona -7 and 8. The range between 8 and -7, it is 15. So you find that 15 boxes zinaweza kuwa tu mzuri, because here I'll use that range to get the suitable scale. So if I use a scale of 1 1 1 1, that 15 can be accommodated on our piece of graph paper. So ukishafili major, utapaki na hii minor. If you want to get this minor, wewe unachukua hii major divide by 5. Kwa nini na divide by 5? Because I want in each and every big square to have 5 division. So because we want it to have 5 division, hii major you will divide by 5. Kama ningetaka ikuwe 10 division, hii major ninge divide by 10. Lakini mimi nataka ikuwe na 5 division. So it will be 1 divided by 5, you get 0.2. Tena uende kwa values za y. You find that maybe in y, because that question was maybe rotation, and rotation can cause any transformation. A figure can be transformed to any quadrant. So if the minimum maybe is something like -5 for y, nimeangalia coordinate zote za y, naona minimum yake ni -5. So I can give allowance, nikikuja kwa graph na mimi nianzie -6. Then nikaangalia maximum yake ikakuwa labda +6. So napeana allowance graph kwa maximum na mimi nifike 7. Unaona hii still kwa transformation, the scale that you used on the major, it is the same scale you are going to use you use on the x, it is the same scale you are going also to use on the y. Kwa nini? Because the figure can be transformed to any quadrant. So changing the scale will end up with wrong answers when you are performing the transformation. So ukishamaliza kuseti hapa, kuja uitoe kwa free, irudi kwa fix. Na hapa fix, hapa inakuanga length ya one big square. Na sasa kupata reading ya hapa, length ya one big square divide by the value yenye umeweka kwa measure. Na length ya one big square, unaona hapo umeweka ni millimeter. Length ya one big square inakuanga kwa centimeters. So that is the same as 10 millimeter. So it will be 10, hiyo unafinya tu kwa calculator, 10 divided by hiyo value ya measure, like this case nimeweka hapo 1. 10 hapo, 10 divided by 1, unapata the answer is 10. Ukishamaliza una click okay. Ukisha click okay, utaona like my case ndio imetoa graph, lakini huku juu imekata, haijafika venye nilikuwa nataka. Huko juu imekata, huko kando imekata, huko kando imekata. So unashika kwa hii kona, una click kwa hiyo graph, na unashika kwa hii green mark. Alafu kama unataka iende kando, una pull kwenda hivi kando. Kama unataka iende chini, una pull kwenda chini hivi. Ukiona haionekani, sababu unaona nikileta hapa haionekani vizuri, you just click here so that you zoom in hakuwa kadogo. Sasa unaona ndio hiyo. So when you close here, unaona clearly our graph imeenda kwa word, na hiyo ndio our graph, ndio hii hapa chini like this. So there's some people maybe who might not want to have this mark. Unaona hizi marks zenye ziko hapa za black hizi mingi, hizi rutoko. Kuna mtu labda anataka kuwa nazo. If you don't want to have them, na hata ushachora huku, useme umeharibu ukiliki ufute, hapana, just hapo click. Hapo click, it will return you back to the system. So ikisha kurudi huko kwa system, tena ukuje uselect hiyo graph. You select, then you right click, alafu uende kwa access. Na hiyo access kuna mahali imekuandikia show ticks. Utoe hiyo show ticks. Na nafinya okay. Kuna sometimes unaweza pata hii line ya y axis na x axis haiko clear, iko mbali, haionekani vizuri venye hii yangu imeonekana. Hii yangu imeonekana because huwa natumia kuchora. So kama haijaonekana vizuri, just right click, go to access, then ukifika kwa access, hapa ikuwe black, that is color, ikuwe black. Hapo pia ikuwe black, then hapa uipeleke 1pt. 1pt itakuwa at least imepita what was the margin for the one big square. So naiweka 1.5, alafu pia hapo 1.5. Kama unataka kwa access hapa at origin ionyeshe 0. Sasa unaona kama yangu nimeiseta hapo origin haijaonyesha kitu. So kama kwa origin unataka ionyeshe kwamba at origin is 0, I right click, then you come to the access, alafu nakuja una select offset. Under origin hapa unaweka offset. Ukiweka offset, then you click okay, utaona hapo kwa origin yenyewe imekuwekea 0. And that's how we set the scale, alafu na click okay. Na load. Good. Ndio hiyo. Let me add another example kwa hii. Let me add another example. Insert, then object. fx2. So maybe you have now a data. Unataka kupea wanafunzi wachore data ya something like linear programming. Hiyo linear programming, I want to avoid so many scales so that we have the uniform scale when you are marking that cases equation. So I want to give it a Cartesian. So just go to the graph function graph, alafu track hivi kwa screen, because usha set haitakusumbua. Ukisha track hivyo, just right click, alafu kuje kwa scale peke yake, then maybe it was running from minimum 0, because hiyo ya linear programming I don't expect kama you will go to the negative, no. So ina run from 0 na inaenda kitu kama 1100. Hiyo linear inequality. So we find that 1200 and 0, the range is 1200. So we find that the most appropriate scale to use, it will be 1 big square 100. Kwa nini? Because hiyo nikitumia 1 big square 100, I'll only have how many division? 12 division, because the range is 1200. So when I divide by 1 major big square, the rate of 1 big square itakuwa 12 division. Lakini unaona ukitumia hapa kitu kama 10. Ukitumia hapa kitu kama 10 inamaanisha when you take the range divided by that 10, you are going to end up with 120 division. 120 division cannot fit on our graph paper. So if it is now 100, hii minor you perform calculation. Major divided by 5. Nafikiri niliandika kwa hiyo steps very well. Major divided by 5. Kama unataka kuwa na 5 division, utaona hii 100 divided by 5, you get the answer is went like that. Then x tuseme ilikuwa inatoka 0, nayo ilikuwa inafika something like which value can I use? Something like let me check maximum, best maximum, and just say illustration. Tuseme kitu kama 900. 900. It is 900. Nataka nitumie kwa yenye iko unique kidogo. 900. Let me use 700. Like that. So we'll find that from here to here, the difference is what? 700, or the range is 700. So you'll find that the 700, I can use a scale like maybe say 50, but still kutumia 100 iko sawa because 100 will get 7 pic square, but I want to use 50 so that at least ikuwe kubwa kidogo. So ikiwa 50, you'll find that minor, it will be this 50 divided by 5. Okay, the answer is there 10. So ukisha set hivyo, kuja uitoe kwa free, urudishe kwa fixed. Now here, hapa ni always, hata kukiwa hapa na namba ingine uchukue tu 10, unaweza find labda kuna mahali umeset default ikachaza hapo namba ingine. Kuchaza hapa it is just 10 divided by measure yake. Unaona hii ni ya x, hapa x, alafu ni ya y. Sasa itakuwa hii ya 10 divided by measure yake which is ya x which is 100, napata hapo 0.1. Haya, hii ingine 10 divided by measure yake unapata hapo ni 0.2 ukifinya kwa calculator. Then kwa wale wenye hatakuwa nataka hizo ticks kuwe, unakuja mahali pa show ticks usitoe, show ticks usitoe. Alafu kama unataka kuwa na origin unaenda kwa offset so that ionyeshe at origin it is what 0, then you click okay. So unaona ni click okay, kwa hii kwenda huku iko sawa, juu ndio yenye imekata kidogo. So kama imekata kidogo, you can just come at the corner here, alafu ni track hii ya green kwenda chini. Good, tunaona hapa kama inanisumbua kuangalia huko juu ati nisungushe hivi, you just zoom in hapa. Alafu unaona hiyo ndio graph yetu. So in case you wanted maybe to label the y-axis and x-axis, maybe y-axis population, then x-axis edges. You just right click on that graph yenye umechora, then you go to axis. Na under axis kuna hapa, si hapa imeandika x and y, hapo x-axis, mid-axis, notation, alafu y-axis, mid-axis, notation. Hapo ndipo penye utaandika. So y-axis, x-axis unataka kuwa na nini? Nataka kuwa na edges. 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 Maybe in years. Edges in years. Just type there. Then kwa y-axis unataka kuwa na nini? Nataka kuwa na population. Population. Like that. Alafu na click okay. So click okay, utaona the y-axis population, the x-axis edges. Unaona nikifanya hivyo tena imekata. Usiachie hapo, kama imekata shika hapo kona, furuta. Unaweza chora time nyingine upate iko hivi. Unaona umetype population on the y-axis, lakini ukiangalia kwa final product population iko mbali sana na hii scale. Same to edges, iko mbali sana na hii scale. Useme umeharibu, shika tu hapo kona. Ukitaka irudi karibu na population, move towards the population. Na ukuwe keen, isikate because unaweza move na uhakikishe uone imekata venye inakata hivi. So kama inakata unarudisha at least. Then huku juu unaona ukipeleka inakata unasongesha chini hadi the last value yenye uliweka kwa graph ya scale ionekane ilikuwa 700 kwa y na kwa x axis 1200. Then ikimaliza I close. So when you close, you'll find that Cartesian inaenda kwa word, inaenda kwa word. So ikienda hivyo kwa word, you'll find that now mwanafunzi kazi yake itakuwa tu plotting. Now when you print this graph, when you save this document and then you print, you'll realize that from here to here, ukipima, it is going to give you exactly 1 centimeter as what is given by the graph. So that is what we discussed about the setting the scales. Now we go next to the next part under the same graph, function graph. How do we use the system to draw the cubic function? How do we use the system to draw the quadratic function? How do we use the system to draw the trigonometric ratio function? How do we use the system to draw an algorithm? So that is what I'm also going to demonstrate. You'll find that here you have been given a scale. Kuna maswali mengine watakupea scale na mengine watakupea scale. So your task, you will fill that table. Table kufill sio kazi ya hii system, ni yako na calculator. So you will fill the table. After filling that table, you check x-axis values. Unaona x-axis values, minimum ni -4. So kwa graph, I can give it allowance so that ianzie -5. Maximum ni 3. So kwa graph, naweza give an allowance so that ifike 4 ama ifike 5. Haina shida. Then kwa y-axis, minimum ni -18. Unaona nikiipea allowance narudi -19, lakini ukiangalia scale imekataa, because scale ya y-axis nayo wanasema kwamba it is of 5 units. So if it is of 5 unit, inamaanisha kwamba the value that you pick as a minimum must be a multiple of those unity used. Hii ingine naanzia -3 -5 because -5 is a multiple of 1. Lakini hii siwezi anzia -18 19 because -19 is not a multiple of 5. So I'll go to -20. Maximum ni 24 kwa hii tepu. So kwa graph 25 iko afadhali na 25 naona ni multiple ya 5. So nikichora I need to consider that. So we'll identify where we have the function graph, then tutaona, alafu jua hizi ni coordinates. So this one under this space I go to insert, then object like that, then fx draw, then okay. Good. Then I go here, function graph. Then you track on the screen like that. Then after tracking, come and select that graph, right click, alafu uenda hapo kwa space. Unaona hapa imepeana space, inaitwa quick entry, quick entry, quick entry. Imepeana hapo space. Hiyo space, just type your function. Our function is y is equal to, it was y is equal to, where is that graph paper? Imekuwa hapa na sasa, let me check. Good, ndio hii hapa. Y is equal to x cubic. X cubic, you type x then followed by 3 without a space. Ukiweka space haitakuwa cubic, itakuwa x3. So x cubic, just type x3 without a space, then plus 2x square like that, minus 5x like that, then minus 6. Then kulingana na hiyo swali unaona wamekupea range. The range is running from -4 less than or equal to x less than or equal to 3. So kuongeza hiyo range, because umesema in the range of, kuongeza hiyo range, ukishamaliza hiyo function weka semicolon, alafu type your function venye iko -4 less than ni shift, then pattern ya less than from your computer, then next from less than naenda kwa is equal to, then ni x shift less than, then from there tunaachilia inaenda kwa is equal to, then inafika kwa 3. Then from there press enter. Ukisha press enter, hizo coordinate utatype hapo. Coordinate is written in bracket. So tutatype hizo coordinate zote, then each and every coordinate tutakuwa na separate na commas. The coordinate is written in bracket. So bracket -4 inapeana -18. That's the first coordinate. Comma, tunaenda kwa second coordinate. On the sentence, usifinye enter, usiteremka pana, linear. Then next, -3, then 0. That's the second coordinate. I go to the third coordinate. The third coordinate, it is -2, alafu ingine ikue 4. Close the bracket like that. Then this one next, it is a -1, alafu ingine ikue 0, close the bracket, open and then comma, then hii ikiwa 0, ingine inakuwa -6 like that, alafu ingine ikiwa 1 inakuwa -8, then hii ingine ikiwa 2, alafu inakuwa 0, then hii ingine ikiwa 3 itakuwa 24. Utype hizo coordinates zote hivyo. Ukisha type tuende kwa scale. Usifinye usikie umemaliza, tuende kwa scale. Kwa scale usaid urudishe kwanza free. So nimesema kwamba minimum ya x ilikuwa negative 4. So tukiwa allowance naweza anzia negative 5. Then maximum ya x ilikuwa 3. So tukiwa allowance naweza ifikisha kwa 4. Naona hii scale si mbaya. Hata ndio umesema use a scale of 1 cm represent 1 unit on the x axis. Sasa hapa itakuwa 1 na hapa 1 divided by 5 0.2. Twende kwa x maximum y naona minimum yake ni negative 18. Na nimesema to use a scale of 5. So a lower value below that is matter of 5 itakuwa negative 20. Maximum naona ni 24. So higher value than that, matter of 5 itakuwa 25 like that. Then hapa major which is the scale walisema tumie 5. So if this one is 5, utaona hii minor itakuwa 5 divided by 5, you get there 1. Alafu nakuja una hii fix. Under fix hizi pia usifanyie calculation. Hapo itakuwa 10 divided by major which is 10. Alafu hapo 10 divided by major which is what? 2. Then ukimaliza tunaweza toa hizo vitu zilikuwa naitwa ticks, short ticks utoe. Then you click okay. Click okay. So you find that this is my graph. But there's something you'll realize that the type of graph that I have, unaona hii haijaweka star, imeweka bullet. Imeweka bullet. Because imeweka bullet, na mimi nataka star, I just select it again, I right click, like this time around sasa unaenda kwa function properties. Na under function properties, enda ukiliki mbele ya hizo coordinate. Use mbele ya coordinate, sio mbele ya function, mbele ya coordinate. Alafu kuja hapa point style. Point style. Point style. Ikuwe the cross. Point style. The cross naweza increase the thickness a bit. Kama hiyo curve, you can try another curve upate hiyo curve sio black. Kama sio black, uta right click and then function properties uko mbele yake na upatilisha hapo color. Haya, kama thickness yake sio ya kuonekana sana, utaenda function property mbele ya hiyo function, then hapa under width uselect which one is a suitable width, alafu kliki okay, utaona imekuchorea. So in real again nimeweka star, lakini huku mwisho mwisho kuna bullet, kuna bullet. So what you do is that unaiselect ifanye hivi highlight, alafu you move the cursor, you move the cursor nearer the curve till the function pops out. We move tu pole pole tu mpaka uone the function pops out kama hiyo, then you right click. Right click, kuna mahali imekwambia domain marks. Hapa mahali pa domain marks, I click so that the tick itoke. Utaona sasa hiyo imetoka. So what is remaining is now to label this function. To label this function again, repeat the same. Select the graph, move the cursor toward the line until the function pops out. If the function pops out, right click, enda kwa add annotation. Unaona ukiadd annotation function ndio hii. Lakini hii function nataka tufanyie some manipulation. So ikishajifomiwa hivyo, right click kwa hiyo function, alafu kuja huku. Rectangular line, nataka hiyo pit ya rectangular line, sio angle line, pit ya rectangular line nataka uiweke 0 ili isionekane hii margin ya nje. Then rectangle color, kuna line na color, nataka color uiweke white so that isikue black ya kuonekana huko. Then kuna hapa kitu inaitwa background. Background nataka ikue white. Then hii kuna hapa kitu ya kusongesha the density of the background color. Unaona huku iko maximum, so utaisongesha minimum. Ni kitu una track tu harutu minimum. Then I want here we have angle line. Unaona angle line nasema none. So angle line nataka ni select line kuonyesha kwamba imepoint kwa hiyo curve kuonyesha labeling. Then ukimaliza hapa penye nimekuandikia sterling pound F1 ya highlight yote, then you type there the function as it is written the paper y is equal to x cubic plus 2x squared and then minus 5x minus 6. So you'll find that as you type here haijaandika kama powers, lakini ukiangalia kwa yenye nimekuandikia hapo iko na powers. So ukiona yenye nimekuandikia hapa haina powers, uangalie hapo kwa kona. Unaona hapa sometimes inaweza kuwa auto haijakuwa haujatick. Kama haujatick utaona yenye nimekuandikia haitakuwa na powers. So you set it to auto. Ukiweka auto utaona hizi zingine inaanza kupea, una type x3 na inakupea x cubic. Then you click anywhere. unapata this is our function graph. So when I close there, unapata kwamba it goes to the what, and that is how we draw a graph. So in case kungekuwa na swali ingine ya using the graph to solve, ingekuwa rahisi tu because like where you can maybe solve like this one, unaona tumepata y is equal 0, y is equal 0 ndio hii, so you just be reading where the line is cutting the y is equal 0 is cutting that curve. Kama hii unaona ukifanya ufike huku una realize that you are ending with a straight line, y is equal to 6 plus y is equal to 6x plus 6. So such a scenario, na unataka hiyo line so that usiprint uchore, you just double click kwa hiyo graph yetu, tuone double click kwa hiyo graph yetu, then you select it, you just click on it to select, then you right click. So right click, kuja mbele penye umemalizia, finya enter, type hiyo equation umepata, which is y is equal to this, y is equal to what, y is equal to 6x then plus 6, y is equal 6x plus 6, na unafinya enter. Usahau kwamba pia ilikuwa na coordinates zake. Coordinates zake ulifanyia hapo kwa box as when x is 0, y ni 6, then hizo to include separated by commas, then we have when x -1, then y is what, 0. So ukimaliza ukiliki okay, unaona ukiliki okay, that is the line. Lakini hiyo line kitu ya kwanza iko na arrow mbele, alafu hizo plot zake ziko star. So select again the curve, peleka arrow closer to that what line. Equation ikipip out, right click, alafu utoe domain, tena uirudishe hapo mpaka equation ipop out, right click. Sasa tunatoa nini? Arrow. Ukishamaliza select again, nataka hizi plot sikuwe star. If you want to change the plot to star, you right click na unaenda kwa properties, na plot ya hiyo ilikuwa nini? Silikuwa hizi zenye ziko huku chini, so una click mbele yake, alafu hapo unaweka point style uiweke star. Good. So there's other time where you can control, na unapata hii line sasa yenye umeongeza, hii line inakuwa color tofauti ama haionekani vizuri, labda width yake ni kidogo. You right click, alafu uende kwa function, then under function, hiyo ni hiyo line. Hiyo line hapa ukiona width yake si kubwa sana, kwa mfano ikiwa 1 ama 0.75 haitakuwa clear, so unaisongesha ipande, then color yake kama sio black unapatisha hapo color, because you can draw another one, then you find the color maybe it is red like that, ni labda hutaki red. So kama hutaki red, you right click on it, you move the cursor toward that right click on that graph, then ukuja kwa function properties, alafu mbele yake na ukuja upatilisha hapa color, uweke yenye unataka which is black like that. So you might need maybe to label this line. To label, I say that you select, una move cursor toward that line what you want to label, then once the equation pops out, right click, alafu kuja kwa add annotation. Unaona sasa nimeshaongeza, unaweza kafuta kuja huku juu hivyo kama unataka, then you right click. Kama umefanya makosa ukaklik anywhere ukakapotea hivyo, useme umeharibu, just click on it. Na ikiwa hii selected, hauwezi select hii mpaka ukuwa umeclick anywhere, isikuwe kama umeselect graph. You uende na arrow direct ukiliki kwa haka box, then you right click, then where we have the rectangular line, nataka ikuwe 0 pt, color ikuwe white, then background ikuwe white, dentro of the background urudishe minimum, angle line uweke hiyo ya pointer, then hapo utype function ilikuwa nini, y is equal to 6x then plus 6 like that. Nasongesha hata hapo juu. Ukiona haonekani, you can click on it, you right click, alafu kuja umake it bold, una highlight alafu click hapo kwa bold, utaona imeonekana like that. So ukimaliza hivyo, if you close, this one is going directly to the word nikifika hivyo kwa what, so we can do anything from there. Good, like that. So unaona solutions zinapatikana where this line now is cutting that curve, which is here, here, here. So taking the readings, it will be very easy, which is the same as -4 here. Then we have -1 here, and finally we have this one, like that. Good. So that is under function, yeah, cubic and quadratic. Then we have this one again. We have this one for trigonometric ratio. Again, the same thing that we have done under cubic function is the same thing you are going to do under trigonometric ratio. Trigonometric ratio. You'll just call the same process. You go to insert, then you go to fx draw, then you if it open, go to the function graph. Then the under function graph, track on the screen. Then you type the function y is equal this one, hiyo y is equal this equation, then tuende hizo same procedures za kuingiza the coordinate. Lakini hapa sasa tutaingiza mara ngapi? Tutaingiza y is equal to this one, alafu tufinye enter, tuweke coordinates zake. Then next y is equal to cos 2x, tufinye enter, alafu tuende na coordinate zake. When x is 0, this one is 1. Tumalize. Then ukimaliza ndio ufinye okay, uone your function yenye itatupea. So let me also do this one, alafu finally tumalize na statistics. So under that space B, the table you are filled. So unaenda kwa insert, unaenda kwa object, then fx draw. fx draw. Like this. Then you go to function graph. Then you come and track on your screen like that. Then you right click. So when you right click, utaona hiyo graph yangu venye inakaa, inaweza anza kukutishia uone kama mambo imeharibika. Just right click on it to select, right click, then ukuja hapo, type the function. What is the function? Y is equal to 3 sin type 2 sin, then kuna open bracket 2x, then plus 30, then close the bracket. Then ilikuwa na range, wanasema 0 is less than or equal to x is less than or equal to 360, like that. Then ufinye enter. Nikifinya enter, tunaenda the coordinate ya hiyo function tumeweka hapo juu. Ni coordinate sema zinakuwa kwa bracket, so that when x is 0, y ni nini? Y ni 1.5. I close the bracket. That is the first coordinate. So after first coordinate, naweka comma ndio tuende kwa second coordinate. When x is 15, y ni nini? 2.6. Then next, when x is 30, y ni nini? 3. Comma. When x is 45, x ni nini? 2.6. Next, when x is 60, y ni nini? 1.5. When x is 75, y ni nini? 0. Then when x is 90, x ni nini? Negative 1.5. When x is 105, x ni nini? Negative 2.6. When x is 120, y ni nini? Negative 3. Next coordinate, when x is 135, y ni nini? Negative 2.6. When x is 150, y ni nini? Negative 1.5. When x is 165, y ni nini? 0. Then finally, when x is 180, y ni nini? 1.5. Oh, maximum was 180, assuming that the range will run to 180, not 360. This one is ranging to 180 increase like that. Then we go to next. Huko mbele ya hiyo penye umefika, press enter. Then we have another function again, y is equal to the cos. Unaona hii iko cos to x. If na type zikifuatana itaandika cos squared. So ukiandika cos na unataka kuongeza digit, you press space then 2x. Then we have the range of 0 less than or equal to x less than or equal to 180 degrees. Ukimaliza hiyo tena you need to write the coordinate. So coordinate juu nimeandika huku juu, I'll just highlight, ni copy, control C, alafu nifinye hapa kwa hiyo space, control B. Then nikuje nifuruta hapa so that I'll just be editing the y coordinate alone. So 0 y coordinate inakuwa nini? Inakuwa 1 kwa hiyo function nyingine. Na hiyo nyingine inakuwa nini? 0.87. Na hiyo nyingine inakuwa 0.5 at 30, 0.5, then at 45 inakuwa 0, then at 60 inakuwa negative 0.87, then at 90 tumia hii arrow kusonga, at 90 inakuwa negative 1, then at 105 negative 0.87, then at 120 it is negative 0.5, then at 135 natumia hii arrow hapa kuna minus mbili, let me bring 1. At 130 I have 0, then at 150 I have 0.5, then at 165 0.87, then at 180 we have 1, like that. So ukishamaliza hivyo na unaenda sasa kwa scale, which is free. Then this one x-axis running from 0 to 180, 0 to 180 kulingana na hii table, 0 to 180. Then ushaambiwa kwamba 1 centimeter represent 15 na 1 centimeter ndio hii ya major, tunaweka hapo 15. So hii ikiwa 15 we find that minor inaenda kuwa 3 because it will be 15 divided by 5, you get 3. Then the y maximum unaangalia highest value of x, it is 3. The minimum value of x is negative 3. So you can give it allowance to negative 4, alafu ingine ikue positive 4. Then ndiye nikuje ni set kwa fixed. Ukisha set fixed, tena hapa kuna kasmala mathematics, it will be 10 divided by major, which is 10 divided by 15. 10 divided by 15. You find that I'm getting 0.66. You're right. Yote 0.66666. Unaona imekatalia hapo. So last it is 7 or decimal point 7. Then hapo it will be 10 divided by 5. You find the answer is what? 2. So ukishamaliza hivyo tunaweza toa ticks under access. Show ticks nilikuwa nishatoa. Natoa ticks. Then hapo show offset tunaweza onyesha offset. Then ukiliki okay like that. So when I click okay, this right click first, scale. This one is what? This one is x-axis. This one is y-axis. So 5 minus, what is this? So major. X major, I will say that 1 centimeter represent 1 unit. 1 centimeter represent 1 unit. Oh, so major ni 1. Then sasa itakuwa 0.2. I was forgetting. So this one will be 10. Then I click OK. Good. So utaona imetuchorea only that hii graph badala ya plot imeweka dot. And then kuna dot at 60 hii. hii 60 kuna mahali tumekosea, inafaa ikuwe negative 0.5. So I can just right click on it. Kuna hiyo curve at 60. This one should be negative 0.5 from 45 0. This one is 0.5, negative 0.5 like that. Good. Unaona imeingia sasa vizuri. So I right click, then I go to function, nianze na ya kwanza coordinate zinaishia hapo before ingine ya pili inaishia hapo. So point style niweke hiyo star, can adjust the size a bit like that. Unaona imeweka sasa star. Then hii ingine tena right click, alafu tuweke right click, then att properties, alafu function properties unafuruta ukuja hapa chini, mbele yake inafaa kuwa point style, tuweke hiyo star, alafu I can increase the size a bit. Then kuna mahali I think we use wrong value, I'll just check. Kuna mahali tulitumia wrong value, ni wapi? Kuna mahali hapa, I think it's here at 75, it is negative 0.87. Let me check hii graph ya pili. At 75 is here, it is negative 0.87. Good. Ilifaa iko hivi. So you'll find that this first curve, hii curve, unaona iko na bullet mbele. So hiyo bullet ya mbele inaitwa domain. Stars ziko sawa, but hii bullet ya mbele inaitwa domain. So you'll select that graph, alafu move cursor toward that line yenye unataka kuedit, then equation ikisha pop out, right click, then remove the domain sample. So utaona hii ndio graph yetu. Then what is remain now is to label this graph. So to label this graph, I click on it to be selected like this with this margin, alafu you move closer till equation imepop out. Equation ikipop out, right click, alafu you add as annotation. Alafu naweza track ikuja hapa juu, ishika tu hiyo na mouse ama na keyboard. Then right click, alafu utype hiyo equation ni nini? Y is equal to 3 sin into bracket 2x, then plus that, plus iko kwa hiyo keyboard yako, then close the bracket. Ukitaka kuweka decrease, we have apostrophe just before one, just click that apostrophe, so long as hapo iko automatic itakuwa hapo decrease. Then rectangular tuiweke 0, color iweke hiyo white, then background weka hiyo white, then what else, the depth of the background tulisha max minimum, then angle line tuweke hiyo ya arrow. So you can highlight this one, then you make it bold like that. So imepaki hii ingine tusha label, imepaki ya chini, click again to select, alafu bring the cursor till the equation pops out. Right click, then add annotation, alafu kuja uifurute ikuje huku chini. Then you right click, na hiyo nayo ni nini? Hiyo ni y is equal to the cos, unaweka space because usipoweka space itaweka square, 2x decrease, unafinya apostrophe just a pattern before one kwa hiyo keyboard yako. Rectangular line tuweke 0, color weka white, then background weka white, then density ya background tuweke minimum, then angle line tayari hiyo iko hiyo, then I highlight, I bold it, then I click anywhere. So utaona kwamba that is the graph. So when I close, it's going directly to our word. Then that is our statistical, our what? Our trigonometric graph. Then lastly, I want to finalize with these things of an ogive. An ogive. An ogive, it is a statistical graph. It is a statistical graph. So you can be given the raw data or the grouped data. So you remember that you cannot draw a histogram or a frequency density if you don't have the grouped data. We normally use the grouped data when we want to draw that histogram. And then on that group data, you should make sure that uh, the data, it is apparent. It is real, not apparent. So you find that from this raw data we have generated here the classes, but these classes, they are not overlapping. Since they are not overlapping, it means that this is apparent class, and apparent class cannot be used to run ogive or a histogram. So in my mind, I can get their real one. So the real one, you just take this one will be what? 26.5, now 24.5. So 24.5, 26.5, 26.5, 29.5, 29.5 to 30.2 point 5, all the way to 44.5 to 47.5. That is our relay classes. And remember that when you want to run ogive, we normally start from the lower boundary of the first class, and we find that the lower bound of the first class is CMF itakuwa 0, because we need to draw an ogive of cumulative frequency y-axis, then x-axis boundaries, and there are boundaries of max. So we find that the lower boundary of the first class, it will be 24.5. And remember that we are running away from these things of breaking an axis. You'll find that even if you check the NAC standard papers, they are coming with those Cartesian already given their origin, not being there broken the axis. So they'll give you the lower boundary of the first class. So I need to start by the lower boundary of the first class. So that lower boundary of the first class, I'll have to take it as 0. So to take it as 0, you mean that you take that lower boundary, subtract itself. Like if I have lower boundary as 9.5, na nataka hiyo 9.5 ikuwe 0, you take 9.5 minus 9.5, you get 0. If my lower boundary is 49.5 na ninataka ikuwe 0, in my mind itakuwa 49.5 minus 49.5 yenyewe. So kumaanisha kwamba to return to 0, in each and every boundary that I have, I'll be subtracting the lower boundary. So tunaenda hapo kwa grid kama kawaida, then insert object like that, then tunaenda kwa fx draw, then okay. I give it time to load, then I remove the grid, then you go to the function graph hapo. Usiende kwa histogram, don't go to statistical data, itakusumbua bure. Enda kwa function graph, then you come and track on the screen. It is a statistical, but do not go to statistical data, just go to the function graph, then you right click, then because we don't have function hii, tutakuwa tunaweka tu hizo coordinate, meaning that tunaanza na lower boundary. Lower boundary ilikuwa 23.5, lakini nimeichukua kama 0, mean that each and every boundary I subtract the lower boundary. So at the lower boundary, the coordinate is x coordinate ni boundary, y coordinate cumulative frequency. So my lower boundary is 0, which is the lower boundary, then cumulative frequency. The lower boundary inakuanga 0, comma. Next boundary, it is 26.5. But 26.5 minus my lower boundary, which was 24.5, I'll get what? I'll get 2. So I go to 2, then frequency yake ilikuwa 3. So after writing this one, hapa ukiandika hiyo sasa, hizi bracket you don't separate with commas, you separate with a wave. Kuna kitu kama wave pattern just before one. Hiyo pattern before one iko na apostrophe na tena iko na wave. If you want to obtain a wave, you press shift na hiyo pattern, shift then hiyo pattern, utaona imekuandikia hapo kwa wave. So that one is what will be doing those bracket in an ogive. So shift your pattern, then next naenda kwa 4, because the other one will be 27.5. 27.5 minus 23.5 4, then frequency yake ni CMF yake ni 10. Next 6, then CMF yake hapo ni 20. Not comma, is that wave? Kwa nini nasahau wave? That wave. Then next tunaenda kwa 8 na CMF yake from 22 napata 38. Hope hiyo ulikuwa ushafeel. Then shift hiyo wave, then tunaenda kwa 10, then CMF yake from 38 tunaenda kwa 49. Then hiyo wave, then bracket naenda kwa 12, then CMF yake it is 56. Next naenda kwa 14, alafu CMF yake from 15 naenda kwa 59. Next naenda kwa 16, then CMF yake it is what? So ukishamaliza hivyo, check what will be the lowest value of x and what will be the maximum value of x. So we find that my lowest value of x is 0, the maximum value of x it is 16. So to give a slight range, I can reach to 17. Or let me reach to 19 so that I have a scale of 1 px square 2. 1 px square 2. Then hii ingine utaona minimum ni 0, then maximum ni 60. So I can use a scale of what? 555. So I go to the scale, then I set it to free. So x is ranging from 0, so nitafika kwa 18 because 18 is a multiple of 2. Then I have a major niweke 2. So when this one's 2, this one will be 0.4 because it will be 2 divided by 5, you get 0.4. Then hii tumeanzia 0 because ilikuwa nafika 60, I can reach it at something like 70, not bad, 70. Then this one 5 iko sawa, itanipea around what? 30 divided by 5, itanipea around 14. So I go now to fix. So fixed, hapo it will be the x, this one will be 5 because it will be 10 divided by the 2 here. Then here it will be the 10 divided by 5 here. You get the answer is what? 2. Then from there tunaenda kwa axis. Then show axis tutoe. But remember that the x-axis inafaa ianzie 23.5, lakini kulingana yenye imechora unaona nikikiliki okay, unaona hii hata imekata. So what you do, unakuja unaiklik huku utrack, you track so that ifike hiyo 70 yenye tumesema. Hii ya mwisho nimesahau kuweka kitu, let me check ni nini nafaa kuweka mwisho. Hii ya mwisho nimeweka compatible ya web, so shift then ya web. So unaona imejoin vizuri. So utaona hizi ni toti, sio cross plot. Side right click niende kwa function, then niende mbele ya hizo coordinate point style niweke star, then I increase the size, then I click OK. So utaona imekuwekea hizo star. But you find that I have not labeled the y axis, I have also not labeled the x axis. Right click, enda kwa axis. So x-axis, there are boundaries of what? Max. Now y-axis, this cumulative frequency. Cumulative frequency. Unaona hii cumulative frequency iko mbali sana na hii scale. So nashika tu hapo kwa corner and start moving low side. Bora uhakikishe usimove ikate. Unaona nikimove sana inakata. So na move tu bora hiyo 18 ionekane. Then next I can now zoom out. This one haikufaa ya ikuwe na 2. This one hii nilimupa assumption by subtracting the lower boundary. So you right click, uenda hapo kwa axis, then show scale on the x axis, utoe isikuwe na scale, so that scale we can enter manually. So unaenda kwa marked point, so that hapo tukuwe na lower boundary which was 23.5, like that. Then from our scale 1 px square was 2. Lakini nikiweka hapa next value zitakuwa pamoja sana. So instead of 1 px square I can skip 2 px square. So if 1 px square is 2, inamaanisha 2 px square itakuwa 4. So this one will be 27.5, then hapa tuende kwa 31.5, then hapa tuende kwa 35, 35.5, then hapa last tunaenda kwa 39, is it true? Is it true? 39.5, 39.5, like that. Good. But I think I missed somewhere from that table. I'm checking the class with 3. Na mimi nilitumia 2. I think that's the error that when counted we can just correct so that hapo x-axis particular hapa 3 2 inafaa kuwe 3, but the same procedure is what will be applied. Unaona sasa when you close here you have come up with what is called an ogive. So an ogive, it will be the coordinate, but now separated with that wave, not commas as we have been doing on that function graph. So that's what I wanted us to note. So I want to stop there. That's what all we discuss about the graph. What is remaining just symbol. We'll also discuss it in our next lesson. Good. Have a nice